Here are solutions to homework set number 11 for ECE 476, Advanced Embedded Systems. This homework set looks at using a Wi-Fi interface with your Raspberry Pi Pico. So here's what I want eventually. I want to set up a web page that's talking to my Raspberry Pi Pico. I can issue commands like clear the starter tree. I can tell it to start the starter tree. So there it started it. The lights turn on one at a time. I can monitor what's going on through a Wi-Fi network. Once all the lights turn on, the race becomes green. It's go. Rev your engine. Brum, 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 brum. It's a bit of time to update. And then I can clear it again. So let's see how we do that. The first problem is just come up with a starter tree where I hit the buttons to start the race. Now, there's a couple ways of doing this. Planning ahead, I'm going to be kind of tied up with the Wi-Fi interface, so I can't really do a bunch of looping. I'm going to use interrupts instead to do all the work. I'll have two sets of interrupts, edge interrupts and timer interrupts. The edge interrupts check the buttons. I'll have the timer interrupt going through the race. So I'll have a couple global variables as well. I've got a global variable called run. When it's 1, the race is starting. When it's 0, the race is waiting. And n is how many lights are turned on. 0, all the lights are off. 16, all the lights are on. Go. And for the timer interrupt, this is going to be called every 500 milliseconds. It's supposed to be 1 second, but I got bored. So made it 500 milliseconds. Every 500 milliseconds, this gets called, passing the global variables n and run. If run is 1, increment n, stopping at 16. If it's less than 16, I'll display n. Otherwise, I'll start filling in the yellow lights. That's actually 50-50. Actually, if n is equal to 16, I'll make all the lights green, and it's go. If run is 0, then I'll set n to 0, turn off all the lights. On the edge interrupts, that's where I check the buttons. I'm going to check for button 15. That is a start. Button 14 is a stop, all with falling edge interrupts when I push the button. And the main routine doesn't actually do anything. It just sits there and displays n and run. So here's how that works. When I start it out, this is what I'm printing out. N and run. When I hit the button 15, let's do that again. Hit button 15. This is run turns 1. I start counting. Once every 500 milliseconds, the lights start turning on. When I get to 16, the green lights turn on. When I hit button 14, that sets run to 0. Clears all the lights. Okay, so that was problem number 1. And let's do that again. Kind of showing you bigger. It's waiting until it starts the race. It's counting. When you get to 16, all the lights turn green. Go! And clears it. All right, going on to problem number 2. Problem number 2 now adds a Wi-Fi interface. I want to be able to monitor what's going on from a Wi-Fi network. And it's your choice if I use AP mode or local area network mode, LAN mode. I'm going to choose AP mode, kind of your choice. To do that, I'm going to set up a web page that's a table that just has 2 parameters. The race status, waiting, go, stop, and the counter. I've got my variables AAA, BBB. They get passed to it. Those are going to get changed. And here's what the display should look like. There's a table, there's your status, green, yellow, red, and the number of lights that are turned on. My web page is going to be stored in my Pi Pico. That's homework11.html. I'm going to open that up and replace AAA with the first parameter, BBB with the second parameter. I will turn on the AP mode on my Raspberry Pi Pico. Then in the main loop, I'm just wait for ping. When I get it, I'm going to update the web page if n is equal to 0. I want to display red and waiting, less than 16, yellow, and n. When it's 16, it's green light, go. So what that looks like, let's go over to Thani. Oops, Thani, there we are. Problem 2, we'll run that puppy. That sets up my web page. Over here, I can connect to my Pi Pico. That's at 192.168.4.1. And that shows up over here. That's my Pi Pico. I can then hit the buttons and start. And it's updating kind of slow. It's got a bad connection here. Let's try that again. Clear. Start it. There's yellow, there's N. Force it to ping. It's supposed to be updating every second automatically. When all the lights are on, it's green. Go. Okay, so that's working now. We'll stop this. Problem 3. I now want to add buttons so I can control from the device, control the starter tree over the Wi-Fi network. So what I'm going to do is add this section of code. Those are buttons using a hyperlink. I've got to pass the IP address. That'll be AAA, and that's going to be BBBCCC. It's a button, and I'm going to return two values, start and clear. So that's what it's going to look like. I've got my two buttons, start and clear. When I click on them, that should start the race, and clear clears the race. The web page has to be updated. I now have to insert IP address for A, then the status and N for B and C. In the main loop, I'm going to sit there and wait for ping. If I get a FAV icon, ping, flag is set. Otherwise, based upon N, change the web page for the status, red, yellow, or green. And then parse it. So here's what she looks like. If I tell it to clear, I echo back this message. I get favicon, host, refer, there's the clear message. So when I parse it, I'm going to strip out everything to the left of refer, this guy right here, strip off everything to the right of the characters from line feed. That just pulls off that message. And as I hit different commands like start, clear, start, start, clear, I get those messages. And now once you hit start, it's going to set run to 1. Starts turning on the lights. And I can see the LEDs lighting up on my web page. When I get to 16, the green light comes on. The race is a go. Then if I want to start a new race, I'll just clear it. And I'm waiting to start the race. So that is homework set number 11. I can control what's happening with the Pi Pico using a Wi-Fi interface, and I can monitor what's going on. Kind of opens up all sorts of possibilities for what you can do with your Pi Pico. Homework set number 11.